Now let's look at an example of a weak base in solution and its conjugate acid. So say I start with ammonia. It's a weak base. It reacts in water to give NH4 plus and OH minus. And it has a value of Kb of 1.8 times 10 to the minus fifth. So for my nomenclature, I have a base, which is ammonia, right here, and I have its conjugate acid, which is NH4 plus. So I have a base reacting with water, and it forms a conjugate acid. So there's always acid-base pairs, conjugate pairs, formed with the reaction in water. So how do I get NH4 plus by itself? What if I had NH4 plus in solution by itself? How do I get that? I can't get NH4 plus in the stockroom, but I could get ammonium chloride, which is a salt, and it dissociates in water to give NH4 plus and the chloride minus ion. And you saw before that chloride minus is a spectator ion, so it's neither an acid or a base. So NH4 plus, this conjugate base, can be formed from just taking ammonium chloride salt and dissolving it in water. Now we have NH4 plus, and since it's a conjugate acid, it's going to behave like an acid in water. And so the acid reaction in water would be to donate a proton. So the acid donates a proton to water. That's a general reaction. And so we're left with NH3 plus H3O plus. So this is the reaction of this conjugate acid in water. It produces the base and H3O plus. So we can find the equilibrium value for this reaction just like before by adding this reaction to the autoionization of water, and this equilibrium constant will be Kw divided by Kb for the base, ammonia, and it's going to be small because we have 10 to the minus 14th divided by 1.8 times 10 to the minus fifth. So this equilibrium constant for the conjugate acid is 5.6 times 10 to the minus 10th. So now I know the equilibrium constant for this reaction. So I can set up the equilibrium expression, letting X be the H3O plus concentration. So NH3 is X, and this is I minus X for NH4 plus. So I'll have X squared over I minus X, and I can solve for X from the quadratic expression. So I'm going to put 5.6 times 10 to the minus 10th in for the equilibrium constant for this reaction and solve for X. The initial amount is not specified. So let's specify one. Say we have 0.01 molar ammonium chloride solution. So I put 0.01 molar in for the initial amount. The X equals 2.4 times 10 to the minus 6. And this is the H3O plus concentration. So we can find the pH directly from the H3O plus concentration, 5.6 for the pH. So it's slightly acidic because this is a conjugate acid reacting with water.